Good evening and thank you for joining me. Today we're doing a Kattis programming challenge and let's get right into it. So this is the Amazing Human Cannonball. The Amazing Human Cannonball show is coming to town and you are asked to double check their calculations to make sure no one gets injured. The human cannonball is fired from a cannon that is a distance x1 from a vertical wall with a hole through which the cannonball must fly. The lower edge of the hole is at height h1 and the upper edge is at h2. The initial velocity of the cannonball is given as v0 and you also know the angle theta of the cannon relative to the ground. Thanks to the innovative suits, human cannonballs can fly without air resistance and thus their trajectory can be modeled using the following formulas. And we get these two formulas. So this is great. And we also have one final constraint here, which is that we have to fit through the wall with a safety margin of 1 meter above and below. Alright, so let's have a look at the input. We will have up to 100 test cases. First line containing the integer n, which is the number of test cases, which will follow. Each test case has 5 parameters, which is everything we talked about before, separated by spaces, and we have also some constraints on the different parameters. Alright, so let's get right into it. I'm gonna start by importing math, because I'm pretty sure we'll need that for the cosine and sinus functions. And then we'll start off by reading the n amounts of input. So we'll go n is int of input. That seems fine. And then we'll do a for loop for that one. For y in range n, and then we'll start off by reading all of our parameters. Let's do something like this, rename theta to t perhaps, no, let's go with theta, x1, h1 and h2 is, let's see, these were supposed to be float, and we'll get all of them in one line. Input. There we go. That was hard to type. Dot split, and we'll split it on space. So that's gonna be all of our inputs. Looks good. And then we're gonna have to start off by getting the angle into radians, because the cosine function will need to have radians instead of angles, which we're getting. But we can do that by just getting the radians of theta, which should be fine. Oh, seems I forgot the math. There we go. That looks a bit better. Alright, so let's see now. We want to get the height at some x point, or we actually know already the x value, but we want to get the height. But right now the function is based off time, so we want to change that up. So let's get time alone, and we get that by doing x, not x, but x1 divided by, let's do parentheses, and we want the angle that we start off times the cosine of the angle. Exactly. Oh, forgot the math again. Perfect. And now we want to get our y value. We get the start angle times the t we got alone. And then we need to multiply that by, almost forgot the math again, math.sine of the angle, which is r. Perfect. And then we need to subtract 0.5 times the gravity, which is 9.81. Oh. And then multiply that by time times time. Oh. Let's get some parentheses around this as well for some added clarity. Great. So now we have our y value of where the cannon will have to pass through, which is great. So now we just have to check whether or not it's within the 1 meter range of the heights that we actually got. So we can do something like if, and let's say now, height 1 plus 1, because we want the 1 meter up, is less or equal to y. And we also want to check if y is less or equal than h2 minus 1. So we get this height minus 1 meter or this height plus 1 meter. And if that's true, it said just at end that we want to print safe. Cool. And else, if it's not, oh, we of course want to print not safe. Alright, so let's find out how this will work. We'll copy this input and we get not safe, safe, not safe, not safe, and a bunch of not safes, and the last two are safe. This might actually work. So let's submit it. We want to go Python 3, of course. Paste our code. And let's see how it went. Alright, that's accepted. So we got that one going for us. Alright, thanks guys for joining me today, and have fun coding.